Hello guys, welcome to H2O, the A to Z of chemistry. I am Dr. RITU JOHAR, your educator for this course, the periodic table. Today we will begin with lecture 4 from the course, but make sure you have watched the previous ones before viewing this one. In the last lecture, we discussed about the modern periodic law, and then I briefly introduced you to the modern periodic table. In this lecture, we would be discussing in detail the features of the modern periodic table. Well, the periodic table is going to be very important for you because this consists all the information about the elements, and this is going to form the basics of your inorganic chemistry, which is nothing but the study of these elements. So, we will begin with a detailed discussion of this modern periodic table in this lecture. So now this is the modern periodic table that you have been seeing from the past few lectures. So let us quickly see what this contains and briefly revise what we've already studied in the last lecture. So this is the periodic table consisting of 118 elements which have been discovered till date. And the whole periodic table, well, I feel this is made up of some bricks, and these bricks are nothing but the elements. And one brick, what has been written on one brick? Well, this is the symbol of the element. Below the symbol, there is the name of the element, and below the name, there is the atomic mass, which is not visible here. But you can see it in any of the periodic table you are having in any of the book that you have. And then on top of the symbol is written the atomic number. Now these elements, they are arranged in accordance with the modern periodic law. That is, they are arranged in order of their increasing atomic numbers, right? So 1, 2, 3, 4 and so on. So they are arranged in increasing order of the atomic numbers. Now we all have discussed it in the last lecture also that this periodic table, this consists of 7 horizontal rows which are called as periods, and then there are 18 vertical columns which we call as the group. And then these 2 rows which you can see beneath the big periodic table, these rows, they are part of the 6th and the 7th period, and we will be discussing them in this lecture only, right? Otherwise, we have 7 periods and we have 18 groups. And now, let us discuss this periodic table in detail. First, we will be discussing the periods, then we will be discussing the groups. Starting with the periods, as you know, they are the horizontal rows from left to right of the periodic table, and there are 7 of them, right? And now, how are the elements filled in these periods? Well, the number of elements in each period is going to be in accordance with the number of electrons in each major energy level, okay? And these energy levels, they are filled in accordance with the of-course principle. So you have to remember the filling of the electrons as you have learned in the energy level diagram. And each period, this is going to start with a new quantum number n. Therefore, if n is 1, we have the first period, n is 2, we have the second period, n is 3, we have the third period, and so on. Coming up to the first period now, so this is going to correspond to n equal to 1, and according to the electron filling, the number of maximum electrons that can be accommodated in any energy level, that is given by 2n square. So putting the value of 1, we will get 2 electrons in the first energy level, and therefore we have 2 elements in the first period, that is hydrogen, and then we have helium. Okay, hydrogen has been placed in the center of the periodic table because it has properties similar to group 1 and group 17. How is it so? We will be discussing in detail when we discuss the course on hydrogen itself. Okay, so but you can remember that it has properties similar to group 1 and group 17, and to avoid the controversy where to place it, it has been placed in the center. But in many of the periodic tables, you will find it placed here with group 1 elements as the first element of period 1 and the first element of group 1. So we have two elements in the first period, hydrogen and helium. Next, we have the second period. So this is going to correspond to n equal to 2, and which has electrons fillings as 2s2 and 2p6. So 2s2 are lithium and beryllium, and 2p6 are boron to neon. This makes it 8 elements in the second period. Third period is going to correspond to n equal to 3, and the number of electrons that can be accommodated in the third third energy level is 3s2, 3p6 and 3d10. So this should make it 18 elements, but if you see the third period, we have just 8 elements. Why is it so? Well, if you remember again the energy level diagram, the 3d orbitals, they have higher energy than the 4s orbitals. So the filling of the 3d orbitals is going to be after the 4s orbitals. Hence, the third period is going to be filled according to 3s2, that is sodium and magnesium, and then 3p6, aluminium to argon. The 3d elements, they are going to go into the fourth period after the filling of the 4s electrons. Okay, so we have the fourth period 4s2, that is calcium, potassium and calcium. Then the 3d electron filling, the 10 elements from scandium to zinc, and then 4p6 filling from gallium to krypton. So these are going to make it 18 elements. Right, now we come up to the fifth period. So fifth period, there is nothing more to add except that it is going to be just exactly same as the fourth period. Now, according to the energy level diagram, again the sixth period, the filling is going to be 6p2, then 4f14, 5d10 and then 6p6. This will make it 32 elements. Okay, and now the first three elements, they are just being filled. The electrons are filled just like the fifth period, no difference. But when you see lanthanum with the atomic number 57, the 58th element, that is the electron is going to go into the 4f orbitals. So 4f filling will require filling of 14 electrons, and those 14 elements corresponding to these electron fillings in the 4f orbitals, they are very much similar to each other and to this lanthanum. Okay, so they are given the same space with lanthanum in the periodic table in the sixth period and the third group. Okay, and now if we want to study about them, we want to see what is the position of those 14 elements, there has been created a separate group beneath the periodic table for these 14 elements, and these 14 elements, they are called as lanthanides or lanthanoids. Okay, and then the next 15 elements of the sixth period, from hafnium to radon, they are just similar filling as the fifth period elements, right? And similar is going to be the case with the seventh period. The 14 elements of the 5f filling, they are going to be placed along with actinium, and the details of this are going to be a series below the lanthanide series that you can see. These are the actinides or the actinoids. All the 14 elements you could see in the previous periodic table that we had. I have not made that over here. Fine. So now we have the lanthanides, we have the actinides, and you can remember over here that the actinides, they are all radioactive elements also. Fine. So this is as far as the periods are concerned. And on this periodic table that you are seeing, the elements, they have been differentiated into metals, non-metals and metalloids also. As you see, there is a regular gradation of the first two periods, the metals which are very reactive metals, going towards the right side of the periodic table, and we reach up to metalloids which have properties different than that of in between that of the metals and the non-metals, and then we have the non-metals at the end of the periodic table. Right. So there is a regular gradation of the metallic to the non-metallic character. This we will be discussing in further lectures also. Right. So this you can see the differentiation into metals, and these are metalloids, and then these are non-metals, and these are the noble gases. Fine. So this is a chart I have made for you for all that I have spoken to you in the periodic table on the last slide. Everything about the periods is written in brief over here so that you can remember and understand this very well. I hope this helps you all. Now we will be discussing about the groups, and if you see, we have the groups from 1 to 18, but along with this 1 to 18 there are some other things written. When first group I have written 1A, 2 is 2A, 3 is 3B, 4 is 4B. So what are these? Well, if you remember the Mendeleev's periodic table, Mendeleev had classified his groups as 1A, 1B, 2A, 2B, right? I hope you remember that. So I have written those along with so that you can understand the relationship between the Mendeleev groups and the modern periodic table. Where have those groups gone, right? Now, to quickly understand how are the Mendeleev periodic table groups related to the present one, you can just understand all 1A to 7A. These were the groups in which the electron, the last electron, was entering into the S subshell or the P subshell. Okay, so first the S subshell, they are going to be 2 electron filling. So again 1A is 1 and 2 is 2A. Then there are 3A to 7A. They are being filled. The last electron is going into the P subshells, the P orbitals. So we have 13 to 17. And the 18th group is the 0 group of the Mendeleev's periodic table, which consists of the noble gases, right? Now what is about the B groups and subgroups and the 8th group, right? So B is going to start with the 3rd, and this has the last electron filling into the D and the F subshells. Okay, so 3 is 3B, 4 is 4B, 5 is 5B, till 7B it is 3, 4, 5, 6, 7. I hope it is easy to remember. Now the 8th group will start with the 8th group of Mendeleev will start with the 8th group of the modern periodic table. 8, 9, 10 are 8 A, B, C of Mendeleev. Now left is only 1B and 2B, which is 11 and 12. I hope this is clear how the Mendeleev groups are placed in the modern periodic table. Some other things that you have to see over here are that the group 1, 2 and 13 to 18, the elements of these groups, they are called as the representative or the normal elements, because the filling of the electrons over here in these elements in accordance with the normal rules of filling. Right, and the 3rd to the 12th group, these groups from the 3rd to the 12th group, they are called as transition elements because there is a regular transition from the metallic to the non-metallic character. Okay, and then we have the inner transition elements, that are the lanthanides and the actinides. And why are they called inner transition elements? Because they are forming a series within the transition elements. A series within the transition, so it is the inner transition elements. right? So these are about the groups, the 18 of them. We will be seeing them more in the coming slides. Now, this periodic table, this has been divided into 4 groups also, according to again the electron filling, right? When the elements, the last electron is entering into the s orbitals, so they are called as the s block elements. Fine. So group 1 and group 2, they are called as the s block elements, and the general electronic configuration is ns1 to 2. For these, it is going to be NS1, and for the second group, it is going to be NS2. Okay. And now, why have we divided them into blocks is because these elements, they will have many properties in common. We will be discussing about the important similar properties of the elements in one block also in the next lecture. But as for now, the S block elements, then the next block we have are the P block elements, where the last electron is going to enter into the P orbitals. So they are going to be 6 groups over here, that is 13 to 18. The exception is helium, where the electron is entering into the S orbital, but this is placed in group 18 because it has characteristics similar to the noble gases, because it has a fully filled energy level and hence it is not reactive, it is a noble gas. You will be understanding all this later, but the exception over here, all these, they are filling in the p orbitals, but helium, the last electron is going into the s orbital. The general electronic configuration for the p block elements is going to be ns2 np1 to 6. And then we have the D block elements. These are from the group 3 to 12, where the last electron is going into the D orbital, right? The general electronic configuration is N-1, D1 to 10, NS0 to 2. And then we have the F block elements, where the last electron is entering into the F orbitals, and the general electronic configuration is N-2 F1 to 14, N-1 D1 to 10, and NS2. And these are the lanthanides and the actinides which are present in the F block, right? So we will be discussing about them in more detail in the next lecture. Now, the elements in one group, as I told you in the last lecture also, they have similar properties because they have similar number of valence electrons, right? So these form a group, and also you can call it as a family of elements which are quite similar to each other. And the first family, there are certain names for these families also. The first family or the first group is that of the alkali metals. The alkali metals, lithium, sodium, potassium, rubidium, cesium, francium, that you have been seeing in the previous slides. And there is a mnemonic which I have to help you learn these also. So we have Li Na Ki Ruby Se friendship, which is lithium, sodium, potassium, rubidium, cesium, and francium. Similarly, the second group elements, they are called as the alkaline earth metals. And to remember them, you can remember the mnemonic Beta Mange Kar Scooter Baap Razi. So we have beryllium, we have magnesium, we have calcium, we have strontium, we have barium, and we have radium. I hope this helps you remember all the elements of the groups. So the next category of families that we have the names for are the 13th to the 18th group, that are the P block elements. The 13th group is the boron family. These are called as the ecosargens, and these ecosargens you can remember from a mnemonic Baggett. B is boron, A is aluminium, G is gallium, I is indium, T is thallium. Then we have the 14th group, that is the carbon family, the crystallogens, and you can remember the mnemonic. Chemistry, C is carbon, Sir gives sundry problems, Sir is silicon, gives is germanium, sundry tin, and then we have lead. right? And then you can remember the mnemonic for the 15th group elements, that is the nitrogen family, the nitrogens, nahi pasand aise sab bhai. Okay, so just figure out what are these elements. You have to learn all of them. Then we have the chalcogens, the oxygen family, and then the mnemonic to remember them also, O style say tail polish. Then we have the halogens, the 17th group, and fir call kar bahar आई auntie. Just see what they mean, okay, and you will find that it is learning very easy. Then we have the noble gases, and the noble gases you can remember from the mnemonic. He never arrived, Kara, zero run pay out. So what are these dark letters? I hope you remember, and you can learn them very well with these mnemonics. Just a sort of help from my side, and then you can figure out some mnemonics to remember the transition and the inner transition elements as well. Now the transition elements, something I have to add over here also. You know now that they are the 3rd to the 12th period. The last electron filling is in the d orbitals, and then the first series of the d elements, they are called as the 3D series, then the 4D series, the 5D series, and so on. And here what I want you to remember is that copper, silver, gold, they are called as the coinage elements. Zinc, cadmium, mercury, they are called as atypical transition elements. We will be discussing why they are called so in the later course. And then there is platinum and gold, that you have to remember they are noble metals. They are not very reactive. So please do remember all of this information. Plus there was some information that I gave you in the last lecture, something very important about the elements that I told you to remember. So please do remember that whole list. These two frequently come in the examinations. Now the last thing left before I finish up this lecture is a diagonal relationship that is seen between certain elements of the 2nd period and those of the 3rd period. So these elements which are diagonally placed, like lithium in the 2nd period and magnesium in the 3rd period, they are quite similar to each other. Then beryllium and aluminium, boron and silicon, you will find that they have properties quite similar to each other, which is because of the similarity in their ionic sizes and similarity of the charge to radius ratio. What all this means, this is going to come further in the course. I am not discussing right now, but you can remember about this diagonal relationship also present in the periodic table. So that would be all for this lecture. In the next lecture, I would be again discussing about the different blocks, the SPDF, and then we would be discussing about the IUPAC nomenclature of elements which have the atomic number greater than 100. So I hope you will join me back for lecture 5 on the IUPAC nomenclature of these elements on our channel H2O. And if you have liked the lecture, please do click on the like link. This really motivates us to work more. Also do subscribe to our channel and click on the bell icon to get a notification as and when we put up a new lecture for you, a new course for you. Any difficulty you have, please do mail us at h2ochemistry@gmail.com, or you can even put that in the comment box. So we will be trying to help you if you have any difficulty. See you again for lecture 5. Have a nice day. Bye bye. God bless you.